Now in this set of problems, we're going to simplify each given expression, and we're going to start off with number 1 here with 6 squared, which of course is 6 times 6, which is 36. That 6 squared, that exponent means that that 6, that base, is going to appear twice in a multiplication. So you can see it twice. Now this number 2, we can think of this two ways. Here's one way to think of it. I can think of it as 8 over 3 times 8 over 3, getting 8 times 8 over 3 times 3, which is 64 over 9, and I don't think that's going to reduce. Now that works. Or you can think of it this way. You can distribute that exponent to the numerator and the denominator. As long as what is inside is a multiplication or division, you can distribute. So I could write this as 8 squared over 3 squared. 8 squared I know is 64. 3 squared I know is 9. So think of it either way. Now let's be careful in this number 3. What is being cubed? What's being cubed is just that 5 that I'm going to write this is not the same as this, negative 0.5 cubed. In this case, the cube applies to the negative, but we don't have that in our problem here. We just have the 3 applying to the 5. So I'm going to bring that negative down. Just bring it along. Now, I've got that 0.5 3 times. So 0.5, okay, well, there's the negative, times 0.5 times 0.5, so I get negative 0.5 times 0.5 times 0.5 is 0.125. Now, we just happen to get lucky here because of this exponent being odd. If I take an odd number of negatives, I know I get a negative. So even if I did this problem incorrectly, like this, if I wrote it as negative 0.5 times negative 0.5 times negative 0.5, I end up with negative times negative times negative is still negative, so I end up with a negative 0. And then those 5s give me the 125. So I'd still get the right answer. But if this exponent was even, we would not. We would get a negative or a positive. Now here in number 4, we're going to square a negative number. And I know if I raise a negative number to an even power, I'm going to get a positive. So the first thing I see when I look at this problem is, what sign am I going to get, positive or negative? Well, negative to an even power, I got an even number of negatives, that's going to be positive. Now I can write this like this, negative 2 over 9 times negative 2 over 9, getting negative times negative is positive, then I get 2 times 2 over 9 times 9, so I end up here with 4 over 81. Or, because I know I'm going to get a positive, I can just distribute this exponent to each of the parts of that fraction, the top and the bottom, numerator and denominator. So I can see this as 2 squared over 9 squared. 2 squared is 4, 9 squared is 81, so I get the same result either way. Now what we're going to do in number 5 is multiply these two powers. Now, I'm going to use this rule right here. Okay, here's the rule I'm going to use. If I have x to the n times x to the m, as long as I'm multiplying, I just add the exponent. So what I'm going to get out of this is x to the n plus m. So what I've got is x to the 6 plus 4, get x to the 10th. Straight multiplication here in number 6. I'm going to have negative 2 times 2, so I'm going to get a negative 4. And then what about these x's? It's all multiplication, so I'm going to have x cubed times x cubed. So it's all multiplication, so x cubed times x cubed. I'm just going to add those exponents. I'll write where it's coming from. Negative 4x to the 6th. Now, number 7, I've got a negative exponent, so here's the rule I'm going to use. If you have some number to a negative power. Now, we're assuming that n is positive, okay? If n is a positive number, this is the opposite of n. So I'm seeing a negative number here. So if I have some base to a negative power, just like this, 3 to the negative 2, what I can do is just flip this over, in a sense, x to the positive n, all right? So just change positions of the base. Now, in this case, the base is in the numerator, right? There's really a 1 here, right? 3 over 1. So just drop it down, just change the position, and change the sign of the exponent. So what I'm going to get here now is 1 over 3 to the positive 2, which gives me 1 over 9. Now, number 8, I've got a number to a negative power. Now, in this case, I'm going to show you what happens here. I get 1 over that number to the positive power, right? Just here's the rule. If you have some number to a negative power, just take 1 over that number and change the sign of the power to positive. So I get 1 over 3 halves, but change the negative 2 to a positive 2. Now, this number down here, this is going to be 1 over, now, 3 squared, 2 squared. So I get a 9 over 4. But I've got a fraction here. I've got 1 over a fraction. So this becomes, think of it this way, 1 over 1 divided by 9 over 4. How do you divide fractions? Invert and multiply. So I get 1 over 1 times 4 over 9, which is 4 over 9. Okay, so what happens now is this. You can take this fraction to a negative number, just flip it over, right? Flip it over and change the sign of the exponent. So what I'm going to do is this. I'm going to write it as 2/3, but now to the positive 2. This works every time, and I just illustrated it over here. All right, so every time what you can do is if you have a fraction to a negative power, change the sign of the power, but flip the fraction over. Now distribute that exponent. So now I'm going to get 2 squared over 3 squared. So I end up with 4 over 9. Okay, let's be careful here in number 9. I've got 3 times 5, which I know is 15. Now look, it's all multiplication, right? No addition, subtractions to foul us up. So 3 times 5 is 15, and then I've got that x squared, and I've got the y squared. Now, these are x's, these are y's, so I cannot just add the exponents, because that applies only if you have the same base. Write this rule, x to the n times x to the m equals x to the n plus m. That you can't use this, you can only use this rule if you have the same base, x and x. Now here, I've got an x and a y, so I can't go any further. We're done here. Number 10, we're going to take the 4 times the 7. Now notice, first of all, I see right up front is all multiplication. No addition, subtractions to hold this up. So all multiplication, so just multiply number parts by number parts. 4 times 7 is 28. Now, move over to the a's. What have we got? We've got 4 here, no more a's, so that's it, a to the 4th. And what about these b's? Well, b's, that's it. Just the b cubed. So that's it for the b's. What about the c's? Well, the c's have got 3 here and 1 here. All right, so now remember, this is really a 1 over here. All right, so if I add those together, I get 3 plus 1. Okay, I get this one. This 3 plus that 1. All right, so we're going to get 28, a to the 4th, b cubed, c to the 4th.